In this video, we're going to take a look at question number 2 from the 2006 AP Chemistry free response questions. So here we have a combustion of carbon monoxide represented in that equation. And it's sort of a weird combustion because we don't have a hydrocarbon, but the CO is burned in oxygen. And in A, it says determine the value of the standard enthalpy change, delta H, for the reaction for the combustion of CO at 298 Kelvin using this information. So this is a Hess's law question where what we somehow need to do is get these two reactions to add up to be this overall reaction, if you want to think about it that way. And so a couple things that I see. Oxygen exists in both reactions, so I don't want to focus on oxygen. So let's focus on just carbon monoxide first. Okay, that's our first compound. And notice the only place carbon monoxide shows up is in the first reaction here, and its coefficient is correct. We have one carbon monoxide overall, and then we have one in this reaction, but it's on the incorrect side. So I know I'm going to have to flip this first reaction, and now that reaction is set in stone, meaning I cannot change it any further, because the only way to get carbon monoxide with 1 as a coefficient and on the reactant side of the reaction is just to flip that reaction. Also, what you may see is carbon dioxide only occurs in the second reaction. Its coefficient is correct and it is on the correct side of the reaction, meaning that CO2 is a product, and so this is just okay. It needs to be set in stone. So by default, the oxygen will have to work out. So this says determine the value of delta H. They don't tell us to justify our answer. So what I'm going to do is I'm going to take delta H, and I'm going to call this, just for convenience, reaction 1, reaction 2. I'm going to take the negative delta H for reaction 1, because I'm flipping it, plus the delta H of reaction 2, and that's going to be negative, then negative 110.5 kilojoules per mole. And this is going to be equal to delta H of my overall reaction. And then plus the delta H of reaction 2, which is negative 393.5. That's kilojoules per mole. And when I add those up, I get negative 283 kilojoules per mole. Okay, so that is my answer for part A. In part B, it says determine the value of standard entropy change for the combustion of CO at 298 using the information in this table. So hopefully when you see a table like this makes you think delta S of the reaction equals the sum of our S products minus the sum of our S reactants. That's the formula we're going to need. So what I'm going to do is I am going to copy this reaction and bring it down for B, and I'm going to say delta S for my reaction equals the S of CO2 minus the S of CO plus 1/2 S of O2. So notice, oops, not CO2, but O2. Notice, even though it didn't seem obvious, I was really multiplying these by 1 because their coefficients are 1. Okay, so now I need to use the table, and what I like to do is check off each one as I plug it in. So CO2 is going to be 213.7. And units for entropies are going to be joules per mole times Kelvin, minus the S of CO, which is 197.7, and then plus 1/2 the S of O2, and that's going to be 205.1, but really we'll end up using half of that. Okay, and that equals delta S for my reaction, and I forgot my little knot. We are at 298 Kelvin, so we are definitely at standard conditions, or standard temperature. And when I do that, I get negative 86.55 joules per mole Kelvin. And let's see if that makes sense. We're going from 1.5 gas moles to 1 gas mole, so we should definitely be losing disorder. That's what we would predict. Okay, so now in C it says determine the standard free energy change delta G for the reaction at 298 Kelvin. To me, I'm making some connections. We just got delta H in A, we got delta S in B, so to me it makes a lot of sense to use the famous Gibbs-Helmholtz equation, which is delta G equals delta H minus T delta S. And a couple things that a lot of chemistry students will mistake at first is delta G needs to be solved for in joules per mole. Delta S is in joules per mole Kelvin, so we have joules per mole, and then when we multiply by temperature, the Kelvin will cancel out. But delta H is almost always given in kilojoules per mole. And we can't take a kilojoule and subtract a joule. They need to be in the same units. So what I always say is make sure you get your delta H to just joules. And so we'll say delta G equals negative 283 and then 000. So multiply by 1,000 is the conversion that we'll do to get from kilojoules to joules. 298 Kelvin is our temperature, and then negative 86.55 joules per mole Kelvin. Plug that into your calculator, and when you get delta G, we're going to get negative 2.57 times 10 to the 5th, or 257,000 joules per mole. Okay. And then, is the reaction spontaneous at 298 Kelvin? Hopefully that's not a difficult question. On the newer AP test, they will not use the word spontaneous. That doesn't show up anywhere on the test because spontaneous, for a lot of people, they think of fast. And spontaneous does not mean fast, it's just asking if it'll happen. So what they'll say is the reaction thermodynamically favorable. That's what they'll ask. Okay, so I would say since delta G is negative, this means the reaction loses free energy, and when this occurs, a reaction is considered thermodynamically favorable. Okay. Now, in E, they say calculate the value of the equilibrium constant KEQ for this reaction. So another equation that should come up, and I know this unit has a lot of equations, but delta G equals minus RT ln of K. Some people call this rattling. We know that delta G is minus 2.57 times 10 to the 5th joules per mole. You should know at this point that R is going to be 8.314 joules per mole Kelvin. Temperature is at 298 Kelvin, and so we need to get ln of K. We're going to divide over 8.314 and 298, and then we're going to get 103.81 equals ln of K. And so we take e to the 103.81 equals K. And if your calculator says overflow air, then you just leave it like that. Or if your calculator can solve it, this is K equals 1.22 times 10 to the 45th.